I'm Mikael Hakansson. Most of you probably know me as the guy who always gets heckled by Kent Weir. A couple of years ago, we made this bet, and apparently I lost, and I was going to be forced to come here to this conference and wear a Canadian jersey. So I'd moved to Australia, right? So I wasn't here. So I think I'd take this opportunity to thank my good friend Johan to take that blame. So I was supposed to use that shirt. Thank you, Johan. I'm going to talk a little bit about reference architecture, very high level, and how to get started to build devices. And then we're going to look at challenges in the real world on how to onboard devices and also how to make updates to devices remotely. So again, this is high level. If you think about devices, and if you read this left to right, Microsoft talks about devices. And I think that's kind of misleading because often you think about the device as the hardware. And in this context, we're talking about the software running on the device. Sometimes you will hear them reference to something called a firmware, which is generally something very low level, close to the operating system. And all of that might be certainly be true when it comes to embedded devices. If you build devices using C# or Node or Java, that will be with a runtime, it's not really qualified for a firmware anymore. So from this point forward, I'm just going to refer to that as an agent. The agent has some kind of reference to an SDK provided by the cloud vendor to solve the communication through the transport. Many vendors use the MQTT protocol, and that is also true for Microsoft, although they prefer using AMQP as a more efficient protocol, AMQP over WebSockets if you're behind a firewall, or even HTTP. And then you move up to the security stack, which is responsible for authenticating the device and to provide certificates or tokens or connection strings for the device, which sits tightly with the device management part of the hub, which is also then a repository of all your devices, and to provide some help and guidance of how to onboard devices. And then you have rules and routing, such as the stream analytics and reports and whatever you want to do with the data later on. And this has greatly been covered by Kent and Steph before, so I will not be covering that part during this talk. So I'm going to start up building a small application. And just to get started, if you go to the Azure IoT SDK on GitHub, this is a great starting point for you if you want to. What? Lost the visual. All right, anyway, thanks. So yes, so the GitHub repo is a great place to start, and you can find things like all the different SDKs for various different platforms, such as C, C#, Java, Node, and Python. So if we start out building a device, I'm going to use build using Node. And so what I've done before I got here, I've downloaded a few NPM packages, which you can find on the NPM site. So if you go to the NPM site and go into search for Azure IoT, you can find that this is the MQP package for the transport. You will need the device, and if you're using other kind of transports like the MQTT, you can download these as well. Apart from that, I've also downloaded a package for a temperature probe that I've got attached to my device called DS18X20. It's a common probe, and I've downloaded this package as well. So those we can see here, those are the modules that I've already installed. For those of you in the back, is this font okay? Can you see it? Good. Okay, so first off, we got this, oh, that was too big. So first off, we got the clients. That's more like a factory class or object from which we can create the device client. And then we have the message, which is going to be a type that we can use to create message, send it to the hub. And then we have the transport. In this case, again, we're using AMQP. But I could download another package if I wanted to. And then we have a connection string, and for this device for number 4, and I can show you later how you can get that connection string. This is not the connection string that you normally get through the portal. It's a device specific to this device. So we start up by creating a client. So our client equals client dot from connection string. There are other methods you can use for if you have just a token, but this is the one that we prefer because if you use a connection string rather than just a token, the SDK will take care of renew that connection string or that token when it expires. So we use the connection string and the transport. And now that we have our client, we're ready to connect and open a connection. So we do client dot open. And this takes a callback. So we use just a anonymous function. And we can check if that is we all right. Let's print out the error. If everything goes okay, we are now ready to do something to read the sensors. Generally, since this is something that's going to be continuing, asking for the temperature for that sensor like every day, every hour, whatever it is. So we need to create some kind of a timer event. So we do a set interval here. This takes a function as well. And an interval which we're going to set to every second. So now we're ready to read the sensors. So I have this package again called that we need to instantiate. We have var sensor. Is 18, 20. So now we are ready to read that into a variable called readings. And I know there is a method on this one called getAll, which gives me all the temperatures on that sensor. And we are now ready to create our message. So we do a var message equals new message. And we need to serialize that JSON message that we now have. So we do json.stringify and set in the readings. Good. So now we're ready to send that message to the hub. So do client.send event. Because when we send messages from the client up to the hub, we're using the event hub that is built into the IoT hub. That's it. So we're done. Now, I have this, I'll save this first. I have this deploy script here. It's just using SCP to deploy to my device. Just open the command prompt and deploy. Good, so that went well. So this is a remote session into the Pi, and now we can see where are we. node app. Please. So while that's happening, so when you debug, just look at that code again. From connection string. From connection string. I'm going to sheets. Trying to figure out what it is. It's from connection string. It's checking I have internet connection. Thank you. So we have this tool called Device Explorer, which is also part of the SDK. So we can connect with this one and see all the devices that we have going. This is a great tool for debugging. So these are all the devices that I have. And the one that we're using is device number 4. So if all goes well here, I should be able to select that device and do monitoring to see them receiving the events. There we go. So what you can see here is that it's 23.6 degrees in here. So that's it. First demo off. Thank you for that one. I'm actually going to stop this one. Okay, cool. So what are the challenges? So what you saw me do now, I actually had this hard-coded, the connection string was hard-coded into my device, my agent, and I connected up to the cloud. Well, in the real world, that really wouldn't work because you might have thousands of devices that you want to onboard, and you definitely don't want to have a specific application or configuration for each of those devices. So generally what you do, you have something unique on the device. Sometimes there is an ID, sometimes there's not. You might, if it's a Wi-Fi enabled device, you might be able to use things like a MAC address or something like that. And then you would have a whitelist of all those devices in the cloud. So when the device logs in, although it's a generic device, it calls up with that ID and register itself. And then the cloud provides, the hub provides a SaaS token back to you, after which you can sign in. Such a solution is not provided within the Azure IoT Hub, but it's something that you would need to build. Another way is, like we have a customer who sells pool equipment, and you can buy from them a small device that you can hook up to your pump at home, and that will measure temperature, pH values, chemical levels, and various things, and provide you with feedback, such as remind you to add more chemicals to your pool and such. And the way that works is it actually has a Wi-Fi hotspot on it. So in this case, we have to do this per device, like one device at a time. So their customer will bring up their phone and attach it to that Wi-Fi hotspot, and then configure and register that device. And from there on forward, it's pretty much the same thing. The SaaS token will, or the connection string will be provided to device and go from there. Before I get into more on devices, I perhaps should have shown you another way, because what I did now, I actually developed using Node.js, and although that is really maybe a very good option, there are other options as well. So for small devices, such as embedded devices, that was actually a device that I planned to do my demos today, but it crashed down and burned last Thursday. It's not the first time, but anyway. So what you can do, you can go to this ARM Embed site, and you can download, or you can not download the device, but you can buy the devices from here, and they have lots and lots of them. And what you can do then is just pick one of these and say, I want to add this to my, first you might want to buy it, but then you can add it to your compiler. And the compiler is up here as well. So this is your IDE, where you develop your applications. So, and it's fairly decent actually. Everything you'll see here is C and C++. It might be a bit overwhelming at first, but basically what you do, you go in and you say, I'll create a new program, and then you go in and say, well, you can add import libraries to this one. And what you will see here is similar to like NuGet or NPM, where you can search for other packages. Azure IoT. And here's the client, for instance. The serializer here is the JSON serializer, and you have various transports for AMQP, HTTP, and MQTT here as well. So I prepared one of those before this presentation. This was the one that was supposed to run, and you can see I've already imported all those packages, like the common for Azure IoT. You have the client. The transport here is HTTP, I think I used, yes, HTTP. And then RTOS is the very low operating system that's running on the device. Then you have things like different sensors that is enabled. And if you look at my code, give me a second. Again, it can be a bit overwhelming if you're not used to C and C++, but it's pretty much the same thing. So you have a connection string, and you have to define the ID of the device as well. I don't know why, because it's part of the connection string, but yes, you have to do that. And then if you go down, there's some helper methods here. But if we go down a bit to the main method, so here we are at the main method. Where did I go? So here we will see creating the client using the same kind of method we did here before with the from connection string. And eventually it builds up a JSON message, and I think we can go even further down. So here we build up the actual message, which is this FRDM device. That's the JSON message that we want to send. And then we read the temperature from the sensor into the temp variable of that object. We then serialize the object into JSON and eventually send the message. It's doable. I want to point out that, yes, there is quite a lot of code, And that kind of segues me into the next topic about managing your applications that you have running on the devices. And I want to just imagine you have 10,000 devices out there, and Microsoft says, comes with a patch, an update. And that's quite relevant here. Everything you see that is in green over here, that has been updated since last week. So this happens, and that might be a security update or something like that, and you need to remotely, preferably, update that device. Otherwise, you would have a service technician running around with a USB stick to 10,000 coffee machines, whatever it is, and making that update. That's not really the way we want to do it. It could also be that any of us wrote a bug. It would be the same thing. We need to provide that updates. So if you look at the code agent that we build, we can divide it into three things. So the core would basically be my main method, which starts the application. The SDK, you might have several. Those are the ones for instance, for Azure IoT to make the communication. If you're relying on that communication to download the software, that might be a problem to actually override and change that code. Other things might be things like I have the reader for the sensor, other packages. Those might be easier to update, while the core part would definitely be the most difficult piece to change. Now, depending on what platform you're running on, if you're running Node, which is very dynamic language, it is compiled, but if you would change any of the scripts during runtime, that would be compiled and you're up running again. That's even true with the core bits. You can change the script, but it won't take effect until you restart the Node process, for which there are libraries to do that. So that's quite easy. When it comes to C# and Java, you might have linked libraries, assemblies that you're using and set reference to. Try not setting reference and build interfaces instead and load them using assembly.load, for instance, so you can deallocate them and load them up again if you download new versions of them. Turns out C and C++ is not strong on any dynamic aspect, and this is where you end up talking about a bootloader, which I love to speak much more about, but I won't have the time today. If you have more questions about how bootloaders are created, I'm happy to talk with you afterwards. So my second demo, my last demo, I have this demo that I'm going to explain to you how you can remotely distribute code to your devices. And this demo is going to be face recognition. So I have a camera, which I'm pretty sure I installed correctly. I might have to change it, but I think I installed it correctly on the device. And we're going to push down that package to the device, read that camera, read my face. It's going to recognize me. And then I have some friends. Saravana, again, thank you very much for inviting us. Of course, I don't think Nino is here. And Kent, which of course is going to play the villain, trying to entering my house. We go back from that one. So I want to introduce you to a tool that I've been working a lot with called microservicebus.com. This is not a platform in itself. In fact, if you sign up, you get to create an organization, and what you do there, you set your Azure IoT connection string, and you can use this portal to manage your IoT hub. So just to show you, we have our nodes. That's what we call our agents. And I have you can see this, the same agents as we saw before. If I go into my Raspberry Pi, there's a NuGet package that you can run, which is start up that device. I think this one is number 1, I think. Yes, that is number 1. Now, these agents don't know anything about any sensors or anything. They only knows about how to communicate with the hub. So we can see that one is online now. The other The other one I'm going to run is going to be on my laptop. So we do node start here as well. So both are online now, and what I want to point out that you see that section where it says services. Down. Can't make it work, but down here there are no services running, and services are the software that's going to run on the device to interact with the boarded devices and sensors and things. So we have 2 nodes online, and we can now go and build our solution. And we call them flows. You can think about it as a scenario. So I'm going to build a new scenario, call it just demo. And this presents me with a design surface where I can start building my, my flow. So I'm going to start off with a camera. And that's a one service. And this is an inbound service. I have many other services here. As outbound, I want to do face recognition. And eventually, I have the door as well. So we just put them together, line them up a little bit. So the last thing we need to do is say on what device is that service going to run. So we go to this one, say this is going to run on device 1. And the face recognition is going to run on device, I can run on device number 1 as well. And then the door is going to be represented by my laptop here, so we say that it's going to be device number 2. So what you will see now is these ones starts up, or shuts down first and then starts up. And you will now see that this one, the device number 1, has now 2 services running, and device number 1, my laptop has the door running. And just before I show you the demo, yeah, the camera is working, that's good. These services are something that you can create yourself. So I only have one here, but what you can do, you can copy or clone any one of the existing ones if you want to. And then what you have here is, I created the door simulator here. So you have the script, but this is the script that we'll be running. So what I want you to put attention to is this one now. Possibly, it takes a picture every 10 seconds, so with any luck, that should come up as me. So and then we have Saravana. If that works. Saravana. Just have to wait for the camera to get ready. I have one more thing to show. This is kind of funny. I took away this picture, but this one freaks me out a little bit. So the thing is that I was the best man, or honored to be the best man of Richard a few years ago when he married Trish, and this was what he gave me as a present. And I can't really look at it. It freaks me out. But I have to try it. So I was trying this the other day and it worked. So I just thought that was pretty amazing. What? Oh. So, worked. So with that, I think I'm out of town. You're free to sign up for microservicebus.com. It's a free site. I was supposed to do a demo with an embedded device, for which there's this guy called Eric Olderman at NXP in Holland who helped me out. I really want to push out thanks for him. And thank you very much. And I'll plug the next speaker. Tomas is going to be up here next. Thank you so much.